Okay, so we're going to take what we did in class today and apply it to both parallel and perpendicular lines and learning how to write equations of those. So if you think back to Friday, all the way then, I know that was a long time ago, we talked about slopes of parallel lines, and we found out that parallel lines have the same slope. So if two lines are parallel, then their slope is the same. All right? So let's go ahead and look at this example and see if we can do it. It says, what is an equation of the line parallel to y equals negative 3x minus 5 that contains the point negative 1, 8. So we've got this line, y equals negative 3x minus 5. We want to write the equation of another line that is parallel to that one. So first of all, in the line that we have, what is the slope? Well, the slope here, as you can see, is what's in front of the x. It's our m, right? So it's negative 3. So that means the slope of our new line is also negative 3 because parallel lines have the same slope. So now what I can do is I can use point slope form, which is y minus y1 equals m times x minus x1, to find the equation of my new line, my line that is parallel to y equals negative 3x minus 5. So we're given the point negative 1, 8. So now we're just going to plug that in. Y minus our y from our point is 8 equals the slope, which is negative 3, times x minus a negative 1, so plus 1. And now this would be the equation of the parallel line in point slope form. What we want to do now is go ahead and see if we can solve it and get it in slope intersect form. Okay? And to do that, all we need to do is solve for y. So if I distribute this negative 3, I get y minus 8 equals negative 3x minus 3. And now if I add 8 to each side, we get y equals negative 3x plus 5. So this is the equation of our line that is parallel to the given line and goes through the point negative 1, 8. All right, and if we were to graph those two lines, you're not going to have to do that, but if we did, I'm going to graph the first one in red. So that would be negative 5. I'm going to make a point there. 1, 2, 3, 4, 5. I didn't even go down far enough, and my slope is negative 3, so I'm going to go up 1, 2, 3 over negative 1. And so this would be the first line. And now I'm going to plot the second line in green. So my second line goes through the point, or it has a y-intercept of positive 5. So I'm going to go up positive 5. 1, 2, 3, 4, 5, make a point. And then the slope is the same, negative 3. So 1, 2, 3 over 1. And I'm going to connect those using a green line. And you can see that those lines do look parallel. They look like they're never going to touch. So that's how to write the equation of parallel lines. So now let's go on to perpendicular, which is a little tougher, but still not that bad. So with perpendicular, think back to Friday. There was something that was true about perpendicular slopes. Well, if you remember, those are negative reciprocals of one another. Negative reciprocals, meaning that their product is negative 1. So A times B would be negative 1. Okay, that makes them negative reciprocals of one another. If A is 1/3, B would be negative 3. You flip and change the sign because those two multiply to negative 1. If A here was, say, 5/8, B would have to be negative 8 over 5. You flip it, change the sign. Okay, so let's look at our problem here. It says we want to write the equation for a line perpendicular to y equals negative 3/4 x plus 3 that contains the point negative 3, 6. Okay, so first of all, here's our equation of our line. We are writing a line that is perpendicular to it, meaning it hits it at a right angle. So we need to find out what the slope of this perpendicular line would be. So the slope of our given line, if you look at it, is negative 3 over 4. So the slope of our line perpendicular to that one would have to be positive 4 over 3. Flip it, and since it's negative, make it positive. So that is really the only part that's different in between doing parallel and perpendicular. For perpendicular, you have to change that slope. Okay? So now it's going to work the same way as our one before did. We're going to use point-slope form to get our equation. So here, we're going to plug in, we have the point negative 3, 6, so we're going to plug that in. So y minus 6 equals 4/3 x minus a negative 3, so that becomes plus 3. So from here, if we want to get this in slope-intercept form, which I will ask you to do on these, we need to go ahead and distribute that 4/3 and move the 6 over to the other side. So let's distribute the 4/3 first. So when we do that, we get y minus 6 equals 4/3 x plus, now I'm going to do over here in red real quick, 4/3 times 3. 4 times 3 is 12 over 3. 12 over 3 equals 4. Okay? So that's going to be plus 4. And so now if I add 6 to each side, that is y equals 4/3 x plus 10. So that would be the equation of my line perpendicular to the given line. So what I want you to do now is try out these two problems on a separate sheet of paper. I will be looking for these in your notes tomorrow, so make sure you do these. And then pause that, and when you unpause it, I'll have the answers up. Okay, so here are the answers to those two questions. In the first one, we wanted a perpendicular line. So if the slope in the given equation was 1/2, the slope for ours had to be negative 2, because that is the reciprocal of 1/2. And so when you plug that into point slope form, you get your final equation is y equals negative 2x minus 18. And then for the second one, if you look at this equation, it's a little harder to see, but that's a horizontal line, meaning it has a 0 slope. Okay? So the slope of a line parallel to it will also have a 0 slope. So when you plug that into point slope equation, you end up with y equals negative 10. All right, see you in class tomorrow.